classroom to hear a variety of projects that students have prepared. Okay, so we have Elon, you're up first?
Yeah.
Okay.
Can somebody connect this video? Yeah, perfect. I don't know that.
Oh, wow. 13 years of education.
Okay. The slideshow should be ready in a moment.
Do you need help?
No, I have it open on here. Is it? If you can
Buggy
fix it,
joint.
I'll fix that.
Buggy.
Okay, here we go. Elon, go for it.
So this is my science experiment. F equals ma, which is the force equals mass times acceleration. My question is, does the arc of a hammer affect the distance of a ball rolling when hit with that hammer? That was what's no. Done. So here's my background information. Newton's second law basically covers this concept. The second law states that the rate of change of momentum in a body is proportional to the force applied, and this change of momentum takes place in the direction of the applied force. So basically, force of the impact, which obviously affects how far the ball will roll, is equal to the mass of the thing that hits it, multiplied by the acceleration of the thing that hits it. So in this case, hypothesis. If the hammer is swung in a longer arc, then the ball will roll farther because the hammer will have more force since it will have more acceleration. This is what I did. And these are the results I got. Basically, as expected, the longer the angle of the longer the arc of the hammer, the farther the ball will roll from its head. My conclusion is not very complicated. It wasn't a complicated thing. My hypothesis was correct because I predicted that the longer the arc of the hammer, the farther the ball would roll, and that's basically what happened. That corresponds with what Newton said. He predicted that this when he set his second law and created the formula F equals ma. What happened was that when I increased the angle hammer, the acceleration increased. And using the formula concept, when the acceleration increased, the force increased. And the more force there is, the farther it will go. So
Okay, so let's see your apparatus at work.
this is what I built. I put the ball here, and I used basically a protractor to measure the angle of the hammer, and then I measured out different angles the hammer was at, and then I measured how far the ball will hit each time.
Okay, so maybe you could demo a couple of times for us.
Sure. I don't have my measure. It's 90 degrees. And voila. Can you go to
Okay, Elon, did you use different balls or just the
No,
one tennis ball?
I just used the tennis ball. Different balls to make it a lot more complicated. And that's not really part of the formula.
Well, if it was a greater mass,
The greater mass, if I wanted to increase mass, I would have used the which I debated doing, but then it's showing us that I shouldn't do that. Yeet.
got it. Okay. Excellent. Good job, Elon. Okay, who's up next? Nadav?
His pants are on. And
Guys, let's speed this up a little bit. Okay, Nadav, tell us what you got.
All right, so
Nice and loud.
my science experiment is if you can use graphite, it's like what it's in pencils and stuff, instead of copper wiring, which is, copper conducts electricity. Wow, because copper is boring and stuff, so should we make it better? So that's the question. So basically, I'm just trying to build a regular circuit with power source, light bulb, thingamajig, and graphite, which is circuit. Yay. Okay. So the hypothesis is if the bulb lights up, then the graphite works because it closes the circuit. Yeah, that's what I use. All right. So this is what happens. You take the battery, connect it in a circuit. It doesn't have to look like a car, in case you're wondering. And then that's the light. Hypothetically, that should light up. That's me doing it. All right, so you draw the circuit, and then you make two gaps on either end. You put the light bulb down, put the LED down. That's what I used originally, but then long story. The LEDs, when I used it on here, they got fried, so I switched to light bulbs. So yeah, hopefully those will get fried. My hypothesis was correct, but if the bar got too thick, then it would not light up, and if it got too thin, it wouldn't light up. So that makes sense. What I would do differently is probably just use copper wire. Regular people do. It's a lot easier and it works a lot better. So at the end.
Okay,
that's beautiful.
good. I could definitely think of some questions for you, Nadav.
Sure.
Is there a benefit to using graphite?
Other than being able to draw quicker, there's no benefit.
Is it cheaper?
Probably. I mean, I don't know how much graphite costs. Probably cheaper than copper,
Okay,
but it
So-
also comes off. Yeah, unless you want to. My mom usually yells at me whenever I try and draw on the walls and stuff, so that probably won't work.
okay. What do you think would be some good follow-up research? What would be, based on this, what else would you want to investigate?
See if different types of graphite or different bar thickness or whatnot probably lights it up more or less.
Okay,
Or just use copper because copper is clearly better at seeing stuff than the rest of the world does.
okay.
The end.
Thank you, Nadav. Okay, good job. Who's up next? Okay, Nathan, where are you setting up?
Yes.
Okay.
It's gonna take 20 minutes. Or not. It has dot.
I know. Okay, Nathan, go ahead. Tell us about your experiment.
So I did an inverted balloon in a bottle.
Okay, nice and loud.
Let me get some.
Any bottles? Okay, that could be helpful to demonstrate.
Okay, so my research question is: if I put more water into the glass bottle, will the balloon inside inflate more? And about this, the water after I put it into the microwave and it's boiled, it turns into water vapor, and the steam gets pushed out of the bottle. And when it cools the bottle, I put the balloon over the bottle, and the water vapor condenses and it turns back into liquid. And this creates a difference in pressure between the inside and the outside of the glass bottle. And since the pressure is higher outside the bottle, the air rushes into the bottle, pushing the balloon down into the bottle and not up and inflating it. And the balloon expands into the bottle. My hypothesis is if there's more water in the bottle, then the balloon will be more inflated inside. Materials I used had a glass bottle, added a tablespoon of water, balloons, and oven mitts. Safe. My procedures, I poured a tablespoon of water using a funnel and placed the bottle in the microwave for a minute, long enough for the water to boil. And once the water in the glass bottle began to boil, I removed it from the microwave. Yeah, and I put the balloon on and making sure to send the balloon. And I took pictures, and this one, the one on the left, is before it went in the microwave, and this was right when it came out, this was the first one was right after I took it out of the microwave, and then a few seconds later, it started to expand, and this is what it was at the very end.
Is the water inside of the balloon?
No, it's at the bottom.
Isn't the balloon supposed to inflate like up?
That's why it's called
No, it's inverted.
And this is a time lapse.
Time's up.
Me pushing it faster than so it works. And that's just that part right there. And was my hypothesis correct? It was correct because when I added more water, the more water continued to cool down and condense back into liquid form, and therefore more air will be pushed into the balloon to make it expand. Conclusion is my experiment worked because when the water inside boiled after I pushed it in the microwave, it turned into water vapor. This water vapor pushed all the air out of the bottle, and then it condensed, it turned back into liquid water. And since the pressure is higher outside, that's why it got pushed into the bottle and not out, and the air rushed in. And I think the amount of time affects the pressure because the more it cools down, the more the balloon expands. The end.
Okay. Good job, Nathan. Okay, so same question for you. What will be your next experiment based on this? What else would you want to know that you would want to test?
I'd probably try it with smaller balloons or see how much
Interesting.
or like different temperatures with water, see if it would expand more or less, and maybe
Excellent.
maybe different size bottles.
Great idea. Very nice. Okay, who do we have next? Rafi?
Oh, it's so nice that you have this.
Okay, so my experiment was I was figuring out if the boys were better than girls at listening to directions.
Oh, okay.
So this is a study not done by me. This is a study out in the lab. But yeah, and when they compared the males to the females proved to be significantly better at listening than the males. But I wanted to try my own study, so my hypothesis was if boys are better at listening to directions, they will make better origami figures and drawings than the girls who they're more attentive. These are my materials. Yeah, I had people from different classes of origami paper. We did a drawing thing too. We gave the class one piece of paper and we gave instructions on what they had to do, and whoever's paper origami figure turned out better won the thing. And for the drawing, gave a set of directions, and whoever followed the directions the best won. We tested on 4th, 7th, and 8th grade, and all grades did 2 rounds of following sections and 2 rounds of drawing based off the directions. The girls won in all 3 classes, and yeah. My hypothesis is proven incorrect because the boys are not very good at listening. In conclusion, the girls are better than boys at following directions, and if I was doing this again differently, I might make sure that the experiment was done quietly, not like this time. Then the subjects might not feel the need to start screaming. Yes. That was my slide.
Okay, good job, Rafi. Can you explain a little bit more about why the subject started screaming?
I don't know. Ask them.
Okay.
They didn't feel like it was a peaceful environment. So
Okay.
Yeah.
Rafi, is there another possible explanation of why the girls did better?
Because they were cheating. No, I mean,
They were cheating. That's why we started screaming.
Well, so hold on,
They looked it
Rafi.
up on the Chromebook.
For a follow-up experiment, Rafi, might you consider doing a different task? Maybe it was the origami
yeah,
that
but
was
it's
hard.
origami. Maybe boys are just better at origami.
Okay, so it's important to consider. So fine, the girls did better each time, but maybe they did better for a different reason. Okay. Okay, who's up next?
Oh, Talia. What?
Oops.
Anyway,
Don't break your
just let her get her project, her.
Yeah, because I don't know what you said.
Chana will.
Okay, go ahead, Talia.
That's very creative today. Okay, my research is that if a marble is heavier, does it go down the roller coaster faster? If you watch the marble closely, you might be able to see that it is going the fastest right at the bottom of the hill before it enters the loop. As the marble rolls down the hill, its potential energy is converted to kinetic energy. A heavier marble will have more kinetic energy because the mass relates to kinetic and potential energy. If you use 2 different weighted marbles, then one will go faster. My procedure is that I made the roller coaster and then I tested 2 different marbles and timed them, and then I recorded my data. This is my observation, and that's that the lighter marble went faster than the heavier marble. If you use 2 different weighted marbles, then one will go faster. My hypothesis was correct. The lighter marble will go faster. My conclusion is that the lighter marble will go faster. In the future, I would probably make the roller coaster out of something else. It was very difficult to make the pool noodle move the way I needed it to. One thing that made my project difficult was the pool noodles were too small for the big marble. What
And then I had to change to a heavier one.
Okay, good job, Talia. So definitely some follow-up experiments would be to have a little bit of a wider noodle for the heavier marble. Okay, good. You have a lot of good theories, but I think we would need a little bit another roller coaster to really to give it another test. Okay, great start. That's what research is all about. You try something, you run into trouble, you try something else. Okay, Baruch, you're up. Okay,
Okay, so my experiment was
Little louder.
coffee testing on children. So, my research question was, how well do children work when caffeinated? The background information was that caffeine gets more effective as you get older because your metabolism slows down and the caffeine stays in your system longer. So caffeine should work, but then go away quickly. And my hypothesis was if children are caffeinated, then they'll be able to learn better because they'll have more energy. My materials were coffee for children. It ended up being 3 children and a Chromebook. So my procedure was that I had the 4 children take a test, and then I recorded their scores. Then I gave them coffee and had them take the same test, and then I recorded their scores. And I recorded data just by typing on my Chromebook. And the record does, without the coffee, the first person got 10 out of 20. The second person got 18 out of 20, but took a lot longer. And the third person got 19 out of 20. And then with the coffee, the first person got 11 out of 20. The second person got 18 out of 20 and took longer. So it was the same thing, but less time. And the third person got 16 out of 20. So my hypothesis was incorrect because it was wrong. In conclusion, my hypothesis was incorrect. Adding up all the scores of the coffee on my test subject got 45 out of 60. This is exactly 2 points less than the 47 out of 60 that my test subjects got without the coffee. And I don't think this was a fluke because the test subjects took the same test twice. The first time without the coffee and the second time with the coffee. And they got a lower score on the second try, which was with the try with coffee. Coffee or not, plain logic says that the second time you take a test, you'll get a higher score because you've already took it. And it wasn't like they took the test in different months, weeks, or even days. They took the same test in 3 hours. So either the coffee affected their memory or I had really bad test subjects. And I think the second option is what happened because I just chose random people who wanted to drink coffee. So if I were to do this experiment again, I would make sure that I had an even split between genders as all of my test subjects were boys. And I would also be sure that they had at least a bit of mathematical ability since I don't think I chose the best test subjects for what I was doing.
Wow.
And even without the coffee, they weren't so good at it. I think I would also try and be more organized and be sure that my test subjects were organized as well because I had a 4th test subject, but because of bad coordination and planning, he had to be cut out of my project. And that's the conclusion of my science fair project.
Okay. Very nice, Baruch. I like, it's a very detailed, what would you do differently? I can see you gave that a lot of thought. That would, I'd be interested to see your follow-up research based on all of the items that you listed.
Eggs, yes.
My research question is, what is a crystal? The background information. A crystal is a solid substance made of organized arrangement of building blocks, such as atoms and molecules. The macroscopic regularity in the shapes of ice crystals, snowflakes, crystalline salts, and gemstones suggests that crystals possess some sort of atomic level regularity. This regularity is referred to as crystal lattice, and every crystal is built upon one. A crystal lattice, an orderly repeating arrangement of atoms, molecules, and ions. The smallest repeating pattern that reflects the macroscopic shape of the crystal is called a unit cell. In general, crystals are extended networks constructed by repeating this unit cell pattern in all three dimensions.
You can go ahead to your hypothesis. No, it's fine. It's great.
My hypothesis is if I add more alum powder, then there will be bigger crystals. These were all the materials I needed, and then this is my procedure, and it took 3 days to complete. I recorded graph.
She's coming to get it right.
Data in a document and pictures, and so I tested it 3 times. One with the amount of alum powder that it directed me to use, and then one with less and one with more. And this one in the top left corner was the one with the most, and it turned out the coolest. Also, it's the same one on the bottom right corner. The coolest. Yeah. My hypothesis was correct. In conclusion, the egg that I put the most alum powder was the coolest and had the most crystals. I think it worked the best because I had more alum powder, so they could make more crystals. I wouldn't do many things differently, and I would probably just put more alum powder in all of them so they would look cooler. I would also probably get different eggs so that I could do it horizontally, and I would change the colors.
Okay, excellent. Good job, Brooke. Okay, we are still in the 8th grade. We have a couple more minutes, a couple more presentations, and then we will move on to the 7th grade. Okay, go ahead, Delia.
My research question was, will different size battery affect the painting? This project is basically trying to create a funny picture related to paint. This project we create the remote control that the marker was connected to produce the electron. My hypothesis is if we use a different battery with a high voltage, then it will have more color in your painting outcome. These are my materials. Next is the procedure.
Do you have any pictures in your?
No.
You did. Okay.
I had 2 paintings, one with different batteries, so they came out different. On the first one, letting it go for 30 seconds, there were 25 short lines. On the second, after letting it go for 30 seconds, there were 40 long lines and 3 different colors. They were pink, green, and blue. My hypothesis was correct because when I used the battery, my motorized color machine moved faster and it went in a straight line. When I used the AA battery, it didn't work as well. They both, the D battery had 1.8 volts and the double S had 1.5 volts. In conclusion, when I used the bigger battery, it was more frequent. I had a better overall drawing. The picture was more complete and the machine moved faster. It also didn't make as much noise and was.
Okay, Delia, could you just talk for a minute? I'm not sure I'm picturing it. It goes around in a spinner.
Yeah.
Okay,
Mine
and
was on the side, and then I put it over paper, and then it would move.
got it. Okay, and what would you do for your next experiment as a follow-up? What would you be interested to find out? Okay, you'll think about that. Okay, excellent. Good presentation. Okay.
So I tested different fruits to find the voltages of them. And my research question was which fruit will have the highest voltage? So background information, any solution containing positively and negatively charged particles, which is most fruits and vegetables, because they have citric acid, can be used as an electrolyte. An electrolyte is a substance that produces an electrically conducting solution. Metals such as copper and zinc have different levels of attraction for the electrons and protons that make them serve as the sites for the electrochemical reactions to take place. So my hypothesis is if all fruits are tested for voltage, then citrus, such as lemons and oranges, will have the highest voltage because they have a lot of acid. My materials were copper wire, iron strips, fruits, and an ammeter. So I put the wire and the iron into the fruit, and I used the multimeter and tested voltages and recorded it. And I put it into a chart. And these are pictures of the testing of the fruit. And then this is my chart. And as you can see, the lemon had most and apple had least, which the apple had 0. My hypothesis was correct because the lemons had the highest voltage, but the orange was not as high as I would have predicted. So in this project, they tested voltages of fruits, and I inserted copper and iron into a variety of fruits and tested the voltages with an ammeter. I attached the red side to the copper and the black side to the iron. I recorded the numbers onto a spreadsheet and made a chart. After recording all of my data, I found that the lemons had the highest voltage. After the lemon, the next highest voltage was the pear and then the kiwi, and they were really close. The clementine was next, and then the banana, and they were also very close. And the fruit with the lowest voltage was the apple, and it had 0. If I were to do this experiment again, I would do a few things differently. I'd probably use a larger variety of fruits and maybe vegetables, and I would use different types of metal to see if that does anything. And I would use different sizes because mine are really small.
Okay. So Shayna, if you had a larger orange, do you think it would have a higher voltage or a smaller voltage? What would you predict? Why?
Because it has more like juice and stuff.
Okay. And okay, great theory. It's worth testing out. And if you had to try some vegetables, which ones would you try, and what do you think might have, based on what you saw?
A potato, because I also tried a different project that didn't work, and my potato had voltage.
Okay. What other
vegetables?
Okay. What other vegetables might you consider trying?
I need that in my fridge because that's my favorite.
Okay, convenience is sometimes in the toolbox of the scientist, but okay, excellent. Okay, good. Good job, Shayna. Okay, we still have another one? Okay, perfect.
Who hasn't gone?
Okay, let's use the last one. Okay, so for anybody just joining us looking for the 7th grade room, we are just finishing up in the 8th grade, and we will be heading to the 7th grade momentarily, as soon as we hear from our last presenter.
Okay, so I made I coded basically I did a code where I found a website that set up a maze for me, and basically I made 2 different people. One person, Ava, who did depth first search, which is basically where she went into the maze, and when she hit a fork in the road, she would guess a plate, a direction, and she would go there. And then if it was wrong, she'd go back, she'd teleport back to the fork, and she would go on a different path. And then there was Ben with the breath first search, where basically he would go forwards one space in one direction, and then teleport back and go another space on the other direction, and then teleport to where he was on the first direction. And who is more likely to get to the end of the maze first. And solving maze can be done just for fun, but it can also help introduce some important concepts into the computer science and programming. A simple maze can be made from arrangement of rectangle cells past those of cells, walls between them. Hypothesis: if you use DFS, which is depth first search, then you will finish the maze faster because you're going faster. Because you're not wasting time going back and forth. My materials, my laptop, and my coding stuff. Procedure, basically I went through, I downloaded the maze, I set it up, I made the code, I ran it, and I kept doing it until I got a working code. And then I ran it 11 times until it worked. I ran it 11 times to figure out the data. I recorded it with a paper and a pencil, and then I transported it to my laptop. I ran the maze 11 times, Ava won 7 times, Ben won 4 times. My hypothesis was correct, and yeah, I basically attempting randomly is better than going back and forth.
Okay. Good job. I think you have a lot of great ideas there, Yitzi. I think for me, if I had some pictures, that would help me understand a little bit better, but I definitely am definitely interested in hearing more of your research about comparing depth first versus breadth first. Okay, good job. Okay, so that's it. That is our 8th grade. We have we had our hammer F equals MA experiment. We had our egg geodes. We had our water bottle with the balloon and a lot of great stuff. Okay, so thank you, Miss T. We are going to the 7th grade room now.